Hi, welcome to PDQ Live. Today we're going to talk about wireless, specifically Wi-Fi 6.
Yeah, the differences between 5, 6, 6E, and why you should care.
Yes.
Why you should even give a hoot.
Well, and who do we have here?
Today we
Intro
have
yourselves.
Austin. He is our network person.
Yeah, network engineer is the title.
Yes, network engineer.
Network child could be defined.
Hey, you're more of a teenager.
Yeah. I think I've graduated into teenager. The angst isn't there, but, you know.
Yeah.
Sometimes.
And then we have Josh. Josh is our IT director, but you're not called that. I don't know what you're called.
The adult in the room.
You're the adult in the room.
Yeah.
On the third floor.
Exactly.
Yeah.
Okay.
Yeah.
We decided to have this webcast because of something that happened here at PDQ that I actually found fascinating. And I think that it is germane to a lot of us. So we wanted to talk about it. So maybe let's start there. Can we talk about what happened in our environment?
I didn't know we were starting this webcast with a rant.
Well, yeah, because it is. I
Yeah.
think it's a rant that affects a lot of people, or will.
So we upgrade our infrastructure on a basis, right? And we upgrade the wireless controller. And after we upgrade the wireless controller, the following Monday, every Mac user in this building could not use wireless at all. It would connect, it would disconnect, it would connect, it would disconnect. And I pulled Josh in, my trusty mentor, to help me figure this out. And we're searching everywhere. We're like, what did we do wrong with this, right? Come to find out that Macs. So we'll explain this a little further, but there are channel widths that you can assign for your wireless. And we were using a basic Cisco wireless controller where it was assigning those channels to 160 megahertz. Well, okay, apparently M2 Silicon can't do 160 megahertz with channels unless you have a certain screen size. I don't know. Any Mac geniuses in the club? Because it doesn't make sense to me. But for some reason, we couldn't do that. So
If you have a 16-inch MacBook Pro, 160 megahertz channel width, fine.
yeah.
14-inch MacBook Pro, nah.
Yeah, exactly. So the fix that we had to do was that we, instead of using 160 megahertz channels, and the reason that this even happened is because we were assigning the best channel width, and Cisco decided that the best has now become 160 megahertz. The 160 megahertz channel widths have been around since 802.11 AC wave, just 802.11 AC, right?
Yep.
Wi-Fi 5. Those channel widths have been available for so long that at this point, I think Cisco is safe to assume that everybody can use 160 megahertz. Well, no, apparently not. So we had to restrict those channel widths to 80 megahertz, right? Which means that your overall, bandwidth availability, the size of that channel has been reduced. So we kind of had to constrict Windows users. Go, look, Windows, yet again, dub for Windows. I'm pretty sure it's like 100 to 2 at this point, but
But maybe tell why you did that, because you had other alternatives. So talk through that, because that was my first question. I'm like, why'd you go that big route? Because you could have done other things. So maybe talk through why you chose that solution.
well, it's like, okay, you've got like a freeway, right? And cars. If the cars are clients, freeway is your infrastructure. We could have changed every car to work with the freeway, right? If the speed limit's 100 miles per hour, but some cars can only do 80, we could have set, let's say Teslas can only do 80 and Fords can do 100, right?
So backward, but got it, yeah.
Yeah.
So you could have made an SSID for the Macs and made them go to that lane, essentially.
Yes.
And limited them to 80.
We could have created an entirely new freeway
Yes.
to accommodate a lower speed, right? We just set the speed limit lower,
For everybody.
even though there are cars capable of higher speeds. We had to reduce that. We decided to reduce that speed in the overall infrastructure instead of per client, right? You can do separate SSIDs, but what we're going to get into is that the plan that IEEE had with creating these new wireless standards is to reduce congestion, right?
Right.
So you create more SSIDs, that's less channels you get to use, right? We're kind of limited in 2.4, 5, and now 6 gigahertz. Again, we'll get into that with 6E, but if you start creating more wireless infrastructure, they're going to start interfering with each other,
Yeah.
right?
Yeah.
I mean, because like ultimately it's just a radio, right? You can only receive or transmit on a frequency at any given time.
Exactly.
So if the more people you have on this or more frequencies that are transmitting, you're going to stomp all over each other, and then more clients have to wait.
Yeah.
And the longer that client wait time is, the slower and or more latency you're going to have in that overall wireless network.
And although your computer may not see it when you open the connect to a wireless dialog, the APs can. They can see, your computer can identify those interferences. There's just a certain, what would you call it? I would say dB, but it would be a signal strength that they'll show you that. But if you were to open any wireless analyzer, right, you could see your neighbor 50 houses down. That's an exaggeration, but the extent of wireless is a lot farther than you might think.
Yeah.
So if we create another SSID, we've also got our neighbors. We're in a multi-tenant building, right?
Yeah.
We've also got any residential networks that are around us, right? So the more interference we introduce, the worse it's going to be for us, and the worse it's going to be for everybody else, because we also introduce more interference for everyone around us,
It's
right?
if we're blaring, it's interfering with them and vice versa,
Right.
and the road and cars and all the IoT devices. And so it's congested 5. So here comes 6 to kind of try to solve some of that in 6E.
Yeah, and I mean, so if we're going to get into it, 6E, the whole point of 6E and 6 is to reduce interference. I think that was the whole point of this newer protocol.
So Kelly, can we look at the first diagram and just kind of show the differences? But I want to clarify one thing. So we did introduce a difference in the infrastructure, but the problem was actually on the endpoints and specifically the Macs. But according to you, the PCs will eventually have the same problem, like maybe end of year, beginning of next year. Is that right?
No.
Oh, no, they won't. Ever?
No.
Sure, right? Like let's say that tomorrow we have a channel width that's available of 320 megahertz. Right. And then the PCs today will do 160 to 240, something like that. You're going to have this like mismatch of channel width at any point. Right. So it's just determining at what point in time you set your channel width versus auto versus best versus what it should be.
Oh, okay.
And like 99% of the time, your wireless controller is going to do this for you.
Yeah, getting
Right.
smarter.
You'll have like this best, better, good, like long distance, like these are the settings you're going to be able to choose, but really under the hood, this is the things that are being changed.
And
Gotcha.
the other point of introducing new protocols is to make it easier for the systems administrator to be lazy. And that is not a bad thing to be lazy, right? In wireless. It's still here, but the need of a contractor coming out and literally identifying the materials in your wall to place APs is reduced because the protocols are more accepting of interference.
Yeah. They can handle it better.
You can almost just shotgun a wireless solution at this point, and it will function. With 6, not even 6E, right? Like we've identified here, the whole point of 6E is to give us a whole new wireless spectrum to work with, because like red-blooded Americans, we just need more space. We can't get it more efficient than we've already got it, so let's just get more.
Yeah.
So somebody paid the FCC a lot of money to get 6 gigahertz.
Open up that frequency.
Yeah, exactly. But it's basically just widening the spectrum that everyone gets to play with, right? Whenever you look up Wi-Fi 6, 6E, they always bring up IoT devices. Like, oh, this is the standard for IoT devices. But what they're saying is there's just more stuff. There's going to be more stuff on wireless than ever.
Yeah.
Right? So they have to create efficient standards
Right.
to handle just all these clients.
Something that can handle more density is
Right.
essentially the whole point of it. So I'm going to throw out some acronyms for you. Ready? This is a big one.
Yeah.
It's OFDMA. So OFDM existed in 5, but OFDMA, it's orthogonal frequency division multiplexing. I'm going to dumb it down. So instead of delivering a load to one client at a time, in 6 and 6E, it can deliver it to all clients together. So that's a big improvement in 6. So it makes it so more clients can get data all at once instead of one at a time.
Yeah. So there's a dictionary of acronyms that they've introduced with 6. The whole point is to stop screaming. Wi-Fi 5 goes like this. Ah!
Yes.
Ah! And what Wi-Fi 6 now does to simplify is it actually comes and talks to you, right?
So Kelly has a little chart that shows that it's not simple, but so one more, Kelly. One more.
There it is.
So
There's the
instead of the
trucks.
truck like doing it one by one to user, it can deliver it to every single person all at the same time. That's like really dumbing it down, but that's the basic.
Yeah, exactly. I mean, OFDMA, MUMIMO, like these things are meant to make each broadcast. There's a cool little YouTube video. It's like 12 years old at this point, but you can hear a wireless access point doing its beacons, right? Or actually transferring data. And it makes each one of those transmissions more efficient.
Yeah.
Right? The whole point at this, I think their move at this point forward with Wi-Fi 7, 8, 9, 10 is going to be to make each broadcast more efficient, because at the end of the day, they're trying to replicate a wired connection to the best of their ability. We perfected this technology in the 90s and in terms of wired transmissions, early 2000s. And nothing beats a good old wired connection, but by golly, they're going to try their hardest. Okay.
Yeah.
They're going to try their hardest, but it makes sense, right? Yeah. Like if I only have to buy, let's say 2 APs for 20 people instead of buying a contractor to run 20 lines and the infrastructure to handle those people, I mean, it makes sense, right?
Yeah. So this is the very first one, and then we're going to talk about a couple more. But so I just want to reiterate. So 6 was meant to handle more clients, have a more dense environment. So it's great for like big companies, outdoor venues, arenas that are going to have hundreds of clients connecting, but there's a cost, right?
Yeah.
So a company needs to decide, is it worth the money for me to upgrade? Because you got to consider how much my infrastructure costs are going to be if you're going to upgrade.
For like if you're ever looking at a technical sheet for an AP, 802.11 AC is 5, 802.11 AX is 6, right? And 6E counts as 802.11 A6, but I would really want to emphasize that you have to pay attention when a distributor gives you a 6E capable access point, because it literally has new antennas, or it can now exist in a new radio spectrum, right? 6 gigahertz.
Do you really need it? Yeah. Okay, so maybe let's talk about some of the features that make it really more efficient and why. So the first one, and Kelly, let's go to the MIMO. So single user MIMO, multi-in, multi-out, existed in 5. And so that's in 6 now we have multi-user MIMO. So in 6 it only was in download, but now it's in upload and download. So this another way to just make it much more efficient, and it can do more clients at once.
Yeah.
So this is another
per beacon efficiency,
Yep, exactly.
basically.
Great for streaming.
The point of MUMIMO is to, like, if you've ever seen a wireless NIC or an AP, when they say 4x4 or 8x8, what they're saying is how many streams can one device alone take, if that makes sense. Yep. So if a device is 2x2 capable and you have a 4x4 AP, that means 2 antennas can talk directly to that client per beacon, increasing the efficiency per beacon for that client, right? And look, don't get tricked. I'm not going to say tricked. If you see Wi-Fi 6E has 9 gigabits per second speeds, that's because of these efficiencies, right? It's not that you're, and that's in a Faraday cage. These speeds are in Faraday cages that have immaculate network conditions, realistically, you are so dependent on Gary who lives next door to your office in that spatial stream. Like you're not going to get the maximum throughput that they advertise. Don't fall for that marketing trick.
And that's the LAN, right? Not per device. That's shared.
That, the bandwidth that they say on those, I really don't understand how they get those numbers. Have they? It's probably one device off one AP with its own connection to some bandwidth tool that they have available to them. But
because I wrote down 5 is 3.5 gigabits and 6 is 9.6. But I think you're right. That's the best scenario.
If you have a 10 gigabit internet connection and only one client off of a 6E8 access point, you got that kind of money.
But maybe it's a LAN, right? Like,
That's what I think.
it's like total throughput. So if I'm a 8x8 AP, right, and I have 2 4x4 clients, MU-MIMO, right? So then I can use all available channels at max channel width to a LAN connection. Given ideal circumstances, sure.
Yeah.
Maybe I can pull down off the backhaul. 9.6 gigabits a second.
Introduce another client onto that AP.
And then all of a sudden that number drops.
Right.
It's halved. It just starts getting...
because I'm a radio, right?
Yeah.
I can only talk or transmit at the same time. So anytime that I'm not talking, I'm waiting to receive my transmission back. And that means that the client behind me is also sitting there waiting in line with their ticket.
And your body, depending on the direction that you're in the AP, if the AP's over here and you're turned away from it, your body is going to interfere with the radio waves. I mean...
But that goes back to, do you really need it? Like, do some research, decide if it's really worth it for your company.
Well,
is what I think.
With the introduction of 6E, like I explained before, it's a whole new, and I would say almost new antennas in APs. You literally have to buy new APs, guys. If you want 6E, the big thing here is if your manager goes to a conference and Cisco or Juniper comes up to you and they're like, oh my gosh, you don't have 6E. You're quite the goober. Here, what is steal? We'll sell it to you for $30,000. Do you actually need that? Do you like the point is what I want to emphasize is that 6E is coming. It's here. But don't purchase $30,000 worth of equipment if it's going to do the exact same thing that 5 and 6 capable APs are going to do.
Yeah.
Right. The efficiencies are there. You have a new spectrum that nobody's really using yet. So you will notice the efficiencies, but it's not worth it for a couple hundred megs in bandwidth. I'm just telling you.
Yeah.
Identifying these differences helps in purchasing. That's the ultimate goal, right? It helps in, do we actually need to create a whole new project for wireless if it's not necessary?
Yeah.
6E also introduced, if you use Wi-Fi 6E, I'm positive that WPA3 and authentication protocol is mandatory, right?
Yes.
I think even in our current environment, we use a group policy with WPA2 enterprise. That would be I would have to rope in a whole other group of people to get this project done because I just want faster numbers, right? Like these are things we have to be aware of when being introduced with new shiny technologies. Is it worth it today?
Yeah. And so in that case, you may be introducing more problems to your network than solutions.
Yeah.
We did, right? Like we upgraded the controller, wanted to take advantage of 160 megahertz channel width.
And look what happened.
We just upgraded the controller to be in line with what our vendor says is the best iOS version for our device. Yeah. And it breaks wireless.
I think we spent 2 days staring at Wireshark and debug logs off of APs.
Yeah. To find out that it's max. Oh, I cannot describe.
Oh, he was so mad.
You can feel the rage building right now.
Yeah.
Rage against the Apple, I swear.
Yeah. Okay, let's talk about 2 more just quick acronyms or protocols. So there's beamforming and basic service set coloring. So beamforming, to me, it just seems like smart signal detection. It just seems like instead of sending the signal out haphazardly, it's just like, I know where Austin's computer is. I'm going to focus my signal there.
That's what I was describing. Okay. Wi-Fi 5, 802.11 AC, like I said, was going, and
Yeah.
hoping that you could, that everyone would get what they need, right? Whereas in 6 and 6E, they are purposely aiming, for lack of a better term, that stream at that device.
Yeah.
Right.
I don't think we should confuse it. Like this antenna is not like aiming, right?
Right.
What is happening is like I'm doing like this client AP negotiation of how far away are you?
The router's aware.
Yeah, how far away are
Yeah.
you? And then I'm going to reduce my transmit power.
Okay.
So that I'm not blasting literally everything all the time.
Yeah.
Yeah.
Which is nice though for interference, though, right?
Yeah.
And yeah, for
Correct.
other. Yeah, I like that.
Yeah. The for the 15th time, the whole point of all this is efficiencies, right?
Right.
And this is one of these cool technologies that they decided to do in protocol that is not required to configure. Or as long as you have an intelligent controller and AP, they can do these things in protocol, which is super interesting.
Well, and you know, what this makes me think of, and Austin and I talked about this, was like the years of having my floor plans and arranging APs according to what I have on floor 1 and floor 2 and floor 3 and having to make sure they're stacked accordingly. But this makes that a little less important, it sounds like, because I don't have to worry so much about treading on top. Is that true?
It's based on if your business requires 9.6 gigabits per second, then yeah, you're going to want to plan based on material interference, bodies. We don't care. Okay,
We did it good enough.
we identified the interference, but you can't plan for the little things, right? We had no idea what the studio would look like, and we've got APs in here. I'm looking at one.
Or this
Yeah.
hanging metal that's behind here.
Right.
Oh, that
This
doesn't
is-
interfere.
This is
That's
a
fine.
nightmare for an access point.
Yeah, the radio waves are bouncing right off, ricocheting, ding, right
Yeah.
off of that.
But this helps that. Like compared to 10 years ago, this fine tunes it so much more. I love that.
Yeah. I mean, we're not like, as of right now, I don't think we even have 6E capable clients at 6 gigahertz. It's not so much that like channel widths are there. I can almost bet that if I were to enable 6 gigahertz only, nobody would be able to use wireless. And that's just because it's a hardware issue, right? The antennas need to be there.
Yeah.
But 6 is perfect.
Yeah.
Perfect balance.
Yeah.
You get the efficiencies that 6E is an extension of 6. The only difference, the big difference is the channels, the new 6 gigahertz, right?
More channels.
But you still get the benefits of 6, whereas you can get beamforming and MUMIMO.
And you can still also kind of directionally point some of your clients at all of the slower protocol speeds as well, right?
The legacy.
Just because like our APs are 6 gigahertz capable, they're also 5 gigahertz capable. They're also 2.4 gigahertz capable, right? So like maybe I have to deploy a printer somewhere. I don't want a printer sitting on my 6 gigahertz
Right.
network, even though it has a radio for it. So I might purposely steer that thing off to 2.4 gigahertz because it's getting print jobs.
Yeah.
And then it's not taking up valuable airtime
Yeah.
on that high-speed network.
Exactly.
So I have a question, and I think maybe other people might have the same question. Why do I care how many channels, and why do I care about channel width?
So we had a diagram that kind of explained
so I think it's, the third one, Kelly.
May have to go back, but
Yes. So
There it is.
tell me about what this all means.
so, okay. So what these channel widths specify, or why you care, is because I'm sure we've all opened a Wi-Fi analyzer. If you haven't, I would emphasize that you do, because you look at your SSID, it's going to be this big long arc that takes up a certain size, right? The size of that arc is the channel width that SSID is using. If you're in a very populated area, you're going to see that sometimes they overlap. You'll have one small channel inside one larger channel, right? And the reason that these things matter is because if channels are overlapping, there's your interference right there in radio itself, right? You're both transmitting within the same radio frequency. You're going to get interference, which means lower speeds,
Okay.
more latency. And when we're talking interference, that's things like jitter, things like latency itself, right? So jitter and latency sensitive applications like phones, which have become more and more wireless, right, these are latency sensitive applications. Letters might get cut off in calls. Streaming like this, if we were on wireless, if the interference that we have could introduce lag in the stream that you may not need or want, right? But these channel widths are important because if you're using 160 megahertz channels, the likelihood of somebody existing inside your channel is very high. It's very high.
So what you're saying, it's kind of like if I'm listening to Metallica, country's going to interfere with it.
Yeah.
And nobody wants that. Yeah. Nobody.
Exactly. It'd be like if a radio channel was, and excuse me, I don't know if a radio station exists on a certain frequency. Let's say it exists on multiple frequencies, and then a college kid comes in and decides to start running his reggae off of a very small channel spectrum. As you're tuning that channel, you're going to run into both at the same time, right? It's that sort of interference. That's why these channel widths matter. We were using 160 megahertz because the population around us isn't that large. We don't have a lot of people around us. The interference was acceptable, right? We do have overlap. With 160 megahertz on 5 gigahertz, if you don't have DFS enabled, you literally only get one section. If you have DFS enabled, you get 2, right?
So you need to be aware of what's around you and watch that.
So what do you use? What is the tool you use to analyze or do any type of mapping? Like, do you have anything that you might suggest?
For tooling, it's whatever pops up on Google first, because everybody seems to have the best tooling available. I'm pretty sure SSID or something like that is pretty useful. There's
We use is it
Metageek.
Yeah, the Haku. I don't know how to say EAHAKU or something like that.
It's this one. He gave me this one.
Yeah, that one. Ekahau or whatever. I don't know.
Ekahau is really good for surveys. If you can install floor plans. I believe it has a certain free trial period, and then you have to pay for it. But if you're doing this day in, day out, it's worth the money.
Yeah. In fact, one of the questions that came in, and we need to get to some questions here.
Okay.
He wanted to know, what do you recommend for site surveys, tools, vendors, things like that?
Ekahau, and there is hardware that is built specifically for throwing it onto your laptop while you're running these survey tools to get you sharper input. So, if you're doing this day in, day out, pay for something like Ekahau, NetSpot. I think it's called WinSSID is good for just getting your channels, like being able to identify channels and interference. But you also have to come in with an idea of what you're looking for, because they're going to spit you just a ton of data. Like there's going to be so much data that you have to know what you're looking for, right? And for me, the big one is interference. If I'm planning something, it's going to be how much interference and what channels are other people around me using. And the problem is a lot of channels get auto-negotiated constantly. So it's like an acceptable level of interference. And if you need to statically set your channel widths and what channels you want to use on your SSID, that would be tools I would use.
Okay. Got a couple more questions for you here. Let's take one. So Cisco changed it from 160 from the 80 or previous frequency it was using?
So to be more specific, there's a algorithm, dynamic channel assignment. I believe DCA uses an algorithm to dynamically update APs to transmit at certain widths. So in an enterprise solution, what's happening is even in your own SSID, you can interfere with yourself. If APs next to each other are using the same channels, you're going to overlap, right?
Yeah.
So what they do is they try to not overlap each other. There's an algorithm that's run where they check around them what channels aren't being used. And based off of the width that you give it, in our case, we were using best. It's in parentheses, best. And in our environment, best is 160 megahertz. That's what we had. And that's how it comes default. They changed best from 80 megahertz to 160.
When you did the upgrade.
When we did the upgrade.
Yeah.
So that was a fault of our own for not really checking the notes to see if they have changed. I forget the algorithm that they run, the name of it, but when they assign channel widths, and it's per AP. Each AP, some APs will be assigned 80 megahertz widths. Some will be assigned 160 megahertz. It's the amount of interference around them based off whatever algorithm Cisco's running to identify what channels are available.
Well, it
and
makes
what
sense that
widths.
they would stagger them. Yeah, and that's why you kept going up to second floor. That was awesome, by the way.
Yeah, because the second floor
Yeah.
didn't have that issue.
Yeah.
All right.
Or third floor, excuse me.
Third floor, that's right.
Got another question for you. Ready?
Yeah.
What are your recommendations for using certs for wireless authentication? James D.
We use certs for wireless authentication. That isn't so much a protocol thing as it is an infrastructure setup. I know, hey, not to tell you, but simple MDM and Connect and Intune paired together, it made it super easy. Super easy. You have to have PKI, first of all. You have to have some sort of PKI that you trust, but then setting up root certs and getting those clients to get their endpoint certs is so easy.
True.
And certs, I feel, are more secure. Something you have, something you know, right? Do both if you can, where maybe a password exists, or you have to have them log in via AD, and then also have a cert. And there you go. You've got what I would consider a very secure wireless network, right? 802.1x over wireless, using wireless. It's super easy to set up. You have to buy infrastructure like Cisco has Cisco ICE, right? Some sort of Radius server. I know there's a Radius server profile. I'm not an AD guy. I'm sorry, but there's a what would you call it? A thing you can install on a domain controller or server role is what I'm trying to say. Windows has its own Radius abilities that you can use. But yeah, I say it's super easy. My recommendations are to find the easiest PKI. I don't like the Radius implementation nor the PKI implementation of AD, but I also am not an AD guy. So it might just seem really hard when it's not. But yeah, you have to have PKI set up first. If you have PKI set up, it's incredibly easy to give your clients those certs using tools like SimpleMDM, Connect, and Intune together.
He's got a follow up also. He says, do you just use a third party cert or do you host them?
So the way I'll give you the sauce. We use a PKI setup called SEPMAN, SCEPMAN. It's an Azure hosted certificate authority. You quickly build it in Azure, and then you point your Intune clients and your SimpleMDM clients to that. So when those computers start up for the first time, they go get a cert that is valid for however many years you set, with a root cert that's generated as that CA is built. So your whole objective is to, one, give each of your clients that root CA. And if you want intermediate CAs, do your thing. But we just have a root CA, and then we have endpoints go get their endpoint certificates, and then they are allowed to join the wireless network once they have that. Yeah, it's super easy, James. I would look into it. Having enterprise wireless on a password is it's not the worst thing. It's better than open, but certificate-based authentication for both wired and wireless is now so easy. At this point, there's so much documentation for it. I would highly recommend it.
Yeah.
Makes it easier. Nobody has to input anything. If you've got a profile on that client, they can just connect to it like it's an open network.
Yeah.
All right. Well, final thoughts on 5, 6, and 6E.
The final thoughts are, as I specified before, if you feel that you need the channels that 6E are now giving, if you are in a very dense environment, you exist in a very metro area, it's worth it. You're going to get a whole new spectrum that it's going to take a few people. Wireless is so dependent on the consumer side of the house, right? If whatever they're selling at Best Buy isn't 6E capable, you can get a good few years of decent channel usage in the 6 gigahertz spectrum. If you're noticing Wi-Fi issues and you are in a dense area, you can use the protocol itself with the new 6 gigahertz channel to get those better efficiencies. I'm going to end this with what I said earlier, though, is that all of this is to just emulate what plugging in a device can do. Oh, man. Get yourself wired. If it's really that bad, just wire yourself up. I'm spitting hot fire right now. You just, like, we love wireless. It's super simple. You can walk around and have a network connection. Everyone can go sit in an area and talk about their favorite coffee without having to be wired. But if it's a very sensitive application where you're really thinking about this, try to wire that sucker in. Just think about it. Just think about it.
Give it a wire.
Yeah, give it a wire.
Yeah.
Give it a wire. Wire not. You know what I mean? Wire not.
Austin Malmborg.
Yeah.
Give it a
Yes.
wire.
Give it a
Give it
wire.
a wire.
All right. Thank you so much, Austin, for joining us.
Yeah, thanks for having me. I love ranting about wireless.
That's it for today. Thanks for watching.
See
I'm
ya.
Tara.
I'm Austin.
Thanks for joining our webcast today. And if you like what you've seen, do us a favor, like and subscribe to our YouTube channel and give us your comments because we absolutely love your comments. If you have additional questions, feel free to reach out to our support forums. And Austin, he's up for side gigs.
Yeah. Oh, for sure. Just hit me up on Discord. I'll answer any questions. I'm in Discord.
There you go. Have a fantastic week. We'll see you back here next time.